Hello everyone, Sartab here. It has been a while since we recorded the last episode of Python optimization for FPL. In this episode, we will talk about how to implement remaining chips, mainly free hit and bench boost, and we will also add a couple of changes to the model so that it will be easier to see what the lineup is, what the bench players are, and what's the total expected points uh, based on your plan. So bench boost is easy to implement, but free hit brings a couple of new variables, and also we need to change the existing variables. We will combine these two into a single one, and so it will be easier for us to go forward and implement new changes. So if there's anything you want to ask, just please let me know. We will also talk about two side constraints. The first one is being forcing the number of transfers in the single game week, and also limiting number of hits, because I know that sometimes optimization, especially during double game weeks, is suggesting taking multiple hits where most people don't feel comfortable to do. So you can customize optimization in a way that you can limit the hits it's suggesting, and it will be easier to digest the suggestions that way. So with that, let me start going over the changes. So as you see, we have our multi-period underscore dev file open. So we will do our changes here. One thing you might have noticed is that we didn't have last time was the login method here. We had to change in the sense that we had to give a user agent and cookie here when logging in, because FPL is changing how login system works. And if the login fails, you will see an error message now. So I have added this outside of tutorial. I'm just going over it quickly. If it happens, then you will see this message. It says, if you're getting this error, do the following, and then it will tell you what to do exactly. So here, so this is the URL you need to visit, and if you visit it, you will see a page in this format. So this is for my team. As you see, it is fantasypremierleague.com/API/my team, and then my team ID. And as you see, it shows you which players you have in your team, the element ID, position, selling price. So mainly why we are trying to get this data is this, accessing the selling price, because as you know, your sell price depends on when you bought the player for which price. And so we are trying to get that information, and also going forward, we will also utilize chips a little bit better. So it will tell us how many chips we still have and if we can use it, and if we have our, let's say, free hit active or wildcard active, so that we can do the rest. But regardless, you need to copy content of this file and put it inside a JSON file by creating under run. As you see here, I have my team.json file here. As you see, it shows my picks, their selling prices. I have already done this. And yeah, that's pretty much it. Now we will first of all talk about forcing number of transfers in a game week. Let's start with that one. So under regular settings, that JSON file, what we will add is num transfers, and I will set this initially to null, meaning that I'm not forcing any number of transfers, and I want to use this as my default method. And I will copy the name of it and come here. So in the dev model, around, so we need to go to the optional constraints. Yeah, over here. As you see, the last time we talked about so we talked about some of these optional constraints in the past. So what I will do is I will add if options get num transfers, and I will call this none is not none. So in here we are checking options dictionary, and we are checking if num transfers, as we wrote here, exist in this dictionary. And so if you don't have this line, so this will automatically get the default value none. But if you have it, let's say if you have this as 1, then this will resolve as 1. And since 1 is not none, we will be able to adding our constraint. We have done it in the past, and then here you can write model add constraint, and then here get expression sum of transfer in, because this controls how many transfers you are making. So the only difference from no future transfer constraint over here is we only want to enforce this for the next game week, for not for the horizon. So I will say for p in players, this should be equal to options num transfers, and the name is transfer limit. I think this should do the trick, and then I will set this horizon to 2 for now, so it will be easier for us to run the model. And let's see, Python sol regular. So this won't force any number of transfers. We are just setting it to null, so this should work as is. As you see, my login attempt failed here, but it's using the team.json file locally. And we set this to 2 horizon, 2 game week, so it will be easier. As you see, it's selling one player and then buying another one. Here, let's force this to 2 transfers this game week. So let's force optimization to take a hit. Let's see how it goes this time. As you see, it's taking, it's transferring 2 players now. It's selling 2 players. Let's try this with 4, and then we will be okay. And as you see, you can also customize this in a way that you can force number of transfers in, let's say, next game week. But we are only sticking with this game week for now. You can do different stuff with this. The structure is the same. As you see now, it's transferring 4 players. So by default, I will set this to null so that it won't have any limits. But if you are wondering about, what's my, let's say expected points for rolling the transfer or transferring a single player, maybe taking a hit, transferring 2 players. So you can maybe even put this inside a for loop and test all of them. That might be an option. After this, as you see, it tells us like which players to transfer, but I don't see my lineup or bench in the output screen. So you need to go to the file and then check it, which, most people don't like. So instead of this, let's customize the summary of actions here. So as you see here in the summary of actions, we are printing the game week name and then how much, your budget, your free transfer, penalized transfers, and number of transfers by cell. But let's try to put this, which players we have. So I will call this lineup players, and this will be, as you know, pixdf is our data frame. So here I will try to pick player entries where the v is equal to w, and I will say end, and I will say pixdf lineup equals 1. So this will filter players who's, from the data frame essentially, where we are checking this game week specifically, and then whoever players are in our lineup. And here I will say summary of actions plus equal, let's put 3 dashes here, and then say lineup. And then here it will be a list of players, and then here you can say lineup players. So this is a filtered data frame. I will get their name column. I will put all of those names into a list, and then I will put this comma here, and then I will say join, so that it will join all those names in that list inside a single string. So this will show names next to each other with comma between them. And here I will say plus new line, and I will do this for the bench players too. Actually, let me copy this. Bench players, and then here this should be bench greater than or equal to 0, because as you might remember, bench variable or bench column here is -1 for players who are not on the bench, 0 for the bench goalkeeper, 1, 2, 3 for the bench order. So by saying greater than or equal to 0, we are essentially saying that these are the bench players. And then I will just copy this. On Visual Studio Code, this is Alt, Shift, and then down arrow, just to copy the same line. So we don't need dashes this time. And I will say bench is equal to bench player's name to list, and then join them the same way. While we're here, we can also add players and their information about the expected points they are giving us. So after this player's sell price, I will add this. I will say multiplier is equal to 1 times is lineup equals 1 plus 1 times is captain equals 1. So it will be 1 for lineup, 2 for captain, and then you can see where I'm going with this, but we can also, in the future, we can also add 1 times is triple captain. I will skip it for now because, I mean, triple captain is not that difficult to implement, and I will leave it for later. And I will say expected points contribution. And here I will say expected points contribution is equal to points player week, player and week we are checking, and then multiply it with the multiplier. So this is the contribution. So give me 1 times expected points for lineup, 2 times of the captain's expected points, and so it will be 0 for the bench player. So I will add this and add it at the end of my here. I will add first of all multiplier and then expected points contribution. So instead of this will be multiplier and XP contribution. And let's see, let's come here and then also print summary of actions plus equal lineup xpts. So you can even put the expected points next to player names over here. I will just keep things simple. I will just take a sum of it and then round and show only 2 digits here. I will say for lineup players get their XP contribution, take the sum of it, and then round it. After this, we can also print a new line and actually triple dashes from earlier, and then I will put some a separate new line so it will be easier for us to see everything. Let's solve this one again. There we go. We are transferring a player in, and then we are selling another player, and we are able to see the entire team discounted. 4, 5, 6, 7, 8, 9, 10, 11 players in our lineup, and then they are sorted perfectly, and then also the bench the same way. It is because our data frame was sorted earlier based on the positions and everything. And for game week 31, it transfers 2 players in, and it sells 2 players, and then as you see, we are able to see the lineup and bench, and also the lineup points 73 for game week 31, only 28.8 for this game week. Okay, now we finished this part. Let's talk about bench boost first. So under regular settings, what I will do is I will add this field called use BB. So this will be the bench boost game week. So the general idea is this: we can give a game week number like 31, meaning that I want to use my bench boost on this game week, or we will be able to set this to null, meaning that I will let optimization choose it for me. And so depending on how we implement the limit here, so we can say that, okay, for bench boost, I only have one. I mean, obviously you only get one bench boost, but it is important to define these limits because, as you know, you never know. FPL might give us a second bench boost, like they gave us the second free hit. So we need another attribute here called chip limits, and then I will write this as a dictionary, or in dictionary format that JSON file format supports. I will say bench boost is equal to 1. Let me write it this way. So if we set this to null, and then if we say that, okay, I have one bench boost I want to use, then optimization will choose it for us. So technically, then you want to keep those 0 because obviously, I mean, for the most game weeks, we are not using our bench boost. So for now, I will keep this at 1, and I will also put wildcard first, 0, free hit 0, and also even triple captain here as 0. So for the future, or when it's time to implement free hit, so we will have the same structure at least, so we can use it. So let's start with the chip limit first. So when we are reading options, let's go up. After free transfer here, I will say, chip limits is equal to options get chip limits. And then if not, then like if we don't pass any chip limits, so this is also important for supporting the earlier versions. So if we don't have this field inside our JSON file, then this will be an empty dictionary, and then we will check later if there's a limit on bench boost or wildcard, and if there is none, if this dictionary is empty, then we will say that you are not using any chips. So if you want to use it, you need to add this chip limits attribute and then set that chip to 1 for the ones you want to use. Let me check here very quickly. Just to keep this consistent with the ones above, let's use a single quote here. And then for chip limits, I think we already have a limit constraint for wildcard over here. So I will actually move this to here. And then instead of calling this wildcard limit, which we were reading from wildcard limit over here, I will just comment this out, and I will use chip limits, and then I will get wildcard, and then I will use 0. This is use wildcard. Let's do the same for bench boost. This is bench boost, and use bench boost. So we have already used our use bench boost variable in a constraint, but we don't have it in our model yet. So let's go here. As you said, this is where we define our variables. The last one we defined was wildcard. So here I will say use bench boost, and then the name is the same. Okay, for bench boost now, So the main change we need to do is here. The lineup number of lineup players is 11 for regular game weeks, or it is 4 times use bench boost W. So now we have 15 lineup players, but at the same time we don't want any bench players. So this should be minus use BBW, because as you know, use BB is a binary variable, so it will take either 1 or 0. If it is 1, 1 times 4 plus 11 will give us 15 lineup players. You know, it makes sense. If it is 1 over here, then it will say that I don't have a bench goalkeeper. And same thing here. I don't want this if use bench boost is active. So one thing we need to change is over here. So we were saying that lineup players should be inside the minimum and maximum bounds. Like I can at least have 3 defense players and then at most have 5. So this should also change, because mainly due to goalkeeper, because goalkeepers, we will have 2 goalkeepers in our squad. Sorry, we will have 2 goalkeepers in our lineup. So, and this was a range constraint. We were saying that this is equal to this lower bound and then upper bound. So we will first of all actually split this into 2 pieces, because lower bound should stay the same. So I will keep this the same, and then I will make this gray less than or equal to, and then I will delete the lower bound part of it. So essentially we split it into 2. This is valid formation lower bound, this is valid formation upper bound, and here now we can say that use BBW. So if we are using our bench boost, then this upper bound you need to relax it by 1, simply because the goalkeeper. You can, I mean, there are different ways to write this down, but this should do the work. And let's see, do I need any other changes? Let's test this first and let's see if it will work fine. And just for now, I will force to use my bench boost on game week 31, because game week 30 and 31 are my future game weeks. If I set this to 0, oh, actually, we haven't forced the bench boost yet, so let me do it first. So the other constraint we need to add is this. We need to force the bench boost here. So again, the structure is actually the same. So I will just copy this. I will say use BB. If it is not none, then you need to add this constraint. I will say use BB, and whichever game week we are looking at, it should be the game week I want to use my bench boost. Let's save this, and then I come here. We will say bench boost 31, and then if I set this to 0, so this should fail. Let's try this first. This should fail because we will force using our bench boost on 31, but then it's 0 here. As you see, it says problem is infeasible. If you have this non-type object has no attribute set value, it means that the optimization failed somewhere, and then we are not able to read the solution. So just check if you can see this line, problem is infeasible. It means that one of your settings is clashing. In this case, it is use bench boost 31, but then again, I don't have a bench boost. So if I set this to null, this should work fine as it was working before. It should give us the same solution from earlier. Yep, seems to be working. So now let's add this 31 and 1, and then run this again. Now this time, if everything works fine, we will see our lineup players, like 15 lineup players and no bench players for the second game week. Goes on, and here we go. So as you see, everyone is in our lineup now. In bench we don't have anyone, but to make it happen, to use bench boost here effectively, it actually transferred more players, which is fine. I mean, this is what we were expecting, then this is great. So now we have this implemented. So yeah, this was bench boost part. For now, I will just keep this at 0 and use bench boost at null because the default setting should be like this. And now let's add use free hit, and I will try to use my free hit this game week 30, and then this should be 1 for our purposes. Okay, free hit is the difficult chip to add here. So let's start with going here and then explaining what's happening. So squad variable is actually keeping which players are in our squad, but essentially when you are on free hit, you have a temporary squad. So it's not, we can't actually use our squad variable for this purpose. Otherwise, we will be transferring, 15, up to 15 players, and then asking optimization to revert it back. So it gets complicated. But the better way to do it is adding a new variable called squad free hit, and this will be for game weeks, and then the name will be squad free hit. So this is a kind of a secondary squad only during free hit that will dictate your lineup and captain, vice captain, bench, whatever. So when you are using free hit, then what we need to do is just making sure that lineup players is selected from squad free hit instead of squad variable. So here we need to add use free hit as a variable, a binary variable. Now here, remember we were counting how many types of players we have. So this should be, we are just copying it and adding squad free hit type count because we need to satisfy it for free hit as well. So the only changes I add FH here, and here we have sell price, but we also need another field called free hit sell price, and I will explain this later. But essentially, free hit sell price is the price you are selling your players temporarily for during free hit, but you're not actually selling your players, right? Because you will get them back. So this will be then for every player, this is sell price P, and this is sell price P for players whose price is modified, because you remember, so we were reading the team information. So I will say sell price P if P in price modified players as by price P for P in players. So this is our sell price for players. And so in the future, if you want to implement a way that you can predict price changes, for example, if you can predict price changes and you want to update this field, this is where you need to update. So this, instead of over P, this should be P and W, and then you will say that for 5 game weeks later, let's say Kane's price will be plus 0.1 to whatever, but we are assuming that the prices will remain the same, and you can actually tackle the budget problem from a different angle. Maybe you can force having a positive in the bank amount, a certain threshold you can put. Anyway, so here we have squad count. We need to add squad free hit count, and we need to count how many players we have during free hit. So now here you always need to have 15 players, like no matter what, even if you are using free hit. But if you are using free hit, then you also need this squad free hit count is equal to 15 times use free hit W for W in game weeks, and the name should be this. By the way, be careful when copying constraints. The names should be unique, and if 2 constraints are sharing the same name, the second one will override the first one, so just be careful about it. Okay, now So the problem part is here. So as you see, we were actually asking optimization to choose lineup players from squad. But if you're using free hit, well, you can't really ask this, right? Because even if that player is part of your team this game week, or let's say last game week, and you're not selling the player for this game week because you're using free hit, and then you will get that player back next when it's next game week after the deadline. So I will add here use free hit W, and since this is a binary variable, we are saying that if I'm using my free hit, I can choose any player for my lineup. It doesn't matter. If this is 0, then they should be a part of my squad. Same thing happens with this. My bench players should come from my squad if I'm not free hitting. So, but the problem is we still need these two constraints for free hit too. So I will just copy this and say that lineup is less than or equal to squad free hit, and this should be +1 minus use free hit. So if this is 0, well, if I'm not using free hit, this will be 0. We will enforce it, and well, technically anyone can be in my lineup as long as they're from my squad. If this is 1, this will cancel, and then this will say that lineup should be part of my free hit squad. And we need this squad free hit variable because we want to enforce how many defenders, midfielders, forwards we can have. So this remains the same. Lineup squad free hit here, and also I made it here so that I won't forget it. Bench again here, this should be free hit +1 minus use free hit. Okay, so we I think fix the issue here. Now I'm checking, we have squad type count, so this should be, we are adding a new one, squad free hit type count, as you see here. Again, this should be within bounds, and so the only difference is we need to multiply this with use free hit W, because if we are not free hitting, then we don't want to have those players, essentially. Yes, so we don't want those players, and I will add FH here, and over here, let's see, so we are saying that we have a team limit. So again, we need team limit for free hit 2. So this will be free hit for being players for that particular type, sorry, for that particular team. So how many players I can have in my free hit squad from that team is less than or equal to 3 times use free hit W, and then team limit free hit. Checking my notes here quickly. Yeah. Okay, so the problem part is, so one of the main problems with free hit is you want to force some kind of transfer constraint, because free transfers will be 1 after you free hit, right? So we have these two constraints that will remain the same, but now we have this constraint that is actually the focus of our free hit squad. So during free hit, you are buying players temporarily, but those players should be within your budget. So what we are doing here is we are adding this constraint and saying that express sum of free hit sell price, remember it was the price of the players, times squad P W -1. So these are the players you already have in your squad. So what I'm saying is, if I sell all of them, that will be your team value or maximum budget you can buy new players, right? And this should be for P in players plus your in the bank amount from last game week greater than or equal to express sum. Now again, you need to use sell price, because if you don't have that particular player, we are using the buy price, right? So you can use this, and then you can say squad free hit. So if I am adding this player to my squad for P in players, and then this constraint should be active for every game weeks, because we don't know which game week we will use our free hit. And the name of this constraint is free hit budget. Okay, now let me check my notes again quickly to see if everything looks fine. Yep, okay. Now, other constraint we need to add is we don't want any transfers during free hit. So this should be transfer in PW is less than or equal to 1 minus use free hit W for P in players, for W in game weeks. Name should be no transfer in free hit. Let's copy this, do the same for out, so we are not selling any players too, and this should be out free hit. Okay. Now here, as you see, we were dealing with the free transfers, and we mentioned that if you are using wildcard, so you need to enforce these. So I noticed an error here. So this should be W minus 1, because it's based on the whether you use your wildcard, last game week, not this one. And we need to do the same like here. So in a way, even if you have one free hit or two, even if you have one or three transfers using, so this should be minus 1, using your wildcard or free hit acts the same way. It is as if you use all of your free transfers. So we are putting -2 here as if, assuming that you have up to 2 free transfers, I use all of them when you use free hit or wildcard here. So then here, yeah, I think that was the only change here. Now for the chip constraints, we need to add this actually, model add constraints, and we will say if you want to use your wildcard, or if you want to use your bench boost, or let's start with free hit. If you want to use your bench boost, you can use only one chip at a time. So you cannot use multiple chips in a game week, so it should be a single chip constraint. Oh, and also we forgot to add for W in game weeks. Yes. All right, so here we were saying that free transfer after wildcard, so this should be free transfer after free hit. So here it should be FH, so our auxiliary variable should get value 0. And here now we have okay, actually let me move these two over here. First of all, let's go over the constraints we always have, and then optionals will come later. And let's see, so we had free, we had bench boost, let's add free hit here. This should be our free hit limit, and then this should be free hit too. And the next constraint related to free hit is this. So we want our squad free hit players less than or equal to use free hit W for P in players, for W in game weeks, aim is equal to free hit squad logic. So what this is doing is if we are not using our free hit squad variable should be equal to 0 for everyone. So this will be actually enforced due to this constraint over here, but we are adding it explicitly. I think we can drop this constraint and it will work the same, but I will keep it just in case because that's how I have in my notes. I will check it later. And if we are forcing free hit on a specific game week, this should be free hit 2 and this should be free hit 2. Yep. And delete this extra line over here. And we have our number of transfers already implemented. When we are reading the solution now, we don't want only this, we also want to print those players whose squad free hit is actually, squad free hit value is actually 1. So, and is squad now is a little bit different because we don't, well, our squad definition is different now. So we will say if you are not using your free hit and that player is in your squad, I will say, or just the other way around. If you are using your free hit, then you want your squad free hit to be greater than 0.5 over here, and here it is captain, and maybe we can even put which chip we are using to here. Oops. We can use, we can add our which chip we are using to here. I will say this chip plus, now we can do this wildcard if use we get value greater than 0.5 else nothing, and I will copy this and use it for free hit, and bench boost if bench boost. And let's add a new line here. All right, so we have lineup players, bench players. I think we added everything. So use free hit 30. So this should give me a free hit squad this way. Let's see. I'm hoping it's feasible. Looks like it's feasible. It's running. Yep. The first solve is completed and the second solve is here. As you see, it says chip free hit and we don't have any chip being used on 31. And for this game week, we are not making any transfers, as you see, but we have a completely new squad. As you see, I have players who have games on this blank game week, and I can see my lineup expected points as 54. I think it was 29 before. Yeah. So here you go. So we added free hit, and what you can do is you can even set this to null now and let optimization decide for us. And since we have set free hit to 1, and then we can even set bench boost to 1. And let's see if it will be able to find that it is better to use free hit this game week. I mean, if you're not penalizing your chips, like if you're not assigning a value to chip, it will always use it right away. So if when we say free hit limit is 1, bench boot limit is 1, and then if we let optimization to find it, it will use it. So only thing I need to warn you is if you are using a longer horizon instead of just 2 game weeks, let's say you are using 5 or 8 game weeks, and if you let optimization to find these chips, this will take a long time. I mean, there are lots of combinations. Especially the problem is even bigger when you have wildcard because it affects everything going forward, and CBC will have a hard time finding it. But if you give the game week directly, like I want to test this idea of using free hit on game week 30 or not, then I suggest you to either write this inside the loop in a way that you force optimization. You tell optimization that, oh, I want free hit on game week 30, and then bench boost on game week 36, and then give me how many expected points you can get, and then try it without, let's say, maybe without free hit or using it on game week 37. So those kind of combinations you should try it yourself instead of letting optimization find it, unless you can actually let it run for a long time. As you see here, we have mentioned in the past, but best possible gives us a bound. This is kind of a theoretical bound. 154 is the bound. So this is, I think we are using objective of expected points, and then we are also giving some weight to the bench players. And then 117 over here is the current best, what we know, and then it will get closer and closer eventually, or the bound will go down, and then at optimal solution they will be the same. So I think we have a time limit of 300 seconds, so there is a possibility that we will hit the time limit, and then at that time whatever solution we have, it will display that as the optimal solution, but it will show us a gap actually. So it will tell us that there is an optimality gap, so that we can either have the optimal solution, but we couldn't prove its optimality, or there could be another, at least another solution where the objective is better. And as you see, it's CBC is talking about nodes and then a tree here. So because branch and cut is a tree algorithm, so it starts from the root node and then splits binary variables who are not 0 or 1 into 2. So it's a little bit technical detail, but so that there are nodes that it needs to evaluate, and then how many nodes on tree. So this should be 0 at the termination because we won't have any active nodes. And as you see, whenever we split it, the number of nodes goes up or on the tree. And then whenever we process, it goes down, and we want it to go down. And I think, as you see here, whenever we find an integer solution, it checks other nodes who are active, and then we check if they can provide a better value. So this could be a major decision of buying Salah on a certain game week, and then it already tells you that some of these cannot be optimal no matter what I do, and then it drops those nodes, or as we call it, it prunes those nodes, and then finally gives us a solution. As you see, it's improving the best solution. I think we will hit the time limit, and while it's working, let us add the hit limit. And then hit limit is a constraint regarding how many hits you want to take over the entire horizon. So I will use this here. I will come here. So we were number of transfers. Where is it? Okay, here I will say if options get hit limit is not none. So hit limit by default should be again null, so that it will translate to none over here. And if we have it, then you need to say model at constraint. So this is a single constraint. This is not constraints, but single constraint expression sum of penalized transfers W for W in game week. Take the sum of all of it. This should be less than options hit limit, and then name will be horizon hit limit. All right, as you see, it finished and it stopped on time limit. And as you see, it is 54 and 82. Let me take a note of this and I will show you, how much faster it gets when we give it by default 30 free hit, 31 bench boost. It hit the time limit, and at the termination, you see that we have a significant gap over here. 135 was the best objective we could find, but 154 was the theoretical bound. And let's see what happens if we just say free hit 30, bench boost 31. By the way, bench boost on 31 doesn't make too much sense, but it's just, we are just trying here. As you see, just in 7 seconds, it found a solution with 54 and 87. So it was 82 when we let it run and then when it hit the time limit. So again, if you are using this, I suggest you to provide this value automatically. I mean, fix it to a game week and then try those that make sense to you. But I will keep this as null over here, and then I will also set these to 0 so you won't use them accidentally. And I will also add use wildcard here because we are merging everything together, so you can give a wildcard and then do the rest. We added hit limit. Oh yeah, let's talk about hit limit first. So when we solve this problem, no chips, as you see, I think it will take hits, if I remember correctly. Let's check it. Okay, it's not even taking hits. That's interesting. Oh, okay. I know what to do. I will say use bench boost on 31. So if we force bench boost, then like the solver will take hits because you need to benefit from those players on your bench. So it will try to pick better players, I think. Let's see. Yeah. So as you see, it's taking a hit this game week and another hit, penalized transfer, next game week. So now let's try this. Hit limit equals to 1. So if I do this, then it should take a hit either this game week or next game week, not in both of them. And we will also try with 0. Penalized transfer 1, and then next game week it only uses the single free transfers, no hit, so it works as we expected. And no hits, I think this is what most people want to do. They don't want to take hits. I mean, you can technically, well, you can force number of transfers, and if your hit limit is like 0, but if you're trying to get, let's say 3 players this game week, then this will clash and then you will see infeasible. But anyway, so as you see, 2 free transfers, it uses both of them are free, and then next game week the same, and then it uses bench boost for a worse lineup expected points. But that's something you can play. I'm changing all of these to null so that you can play with it, and yeah, that's it. So I will push these changes to the GitHub repository. You can pull it and then you can also try it from there. But again, I suggest you to have a look, and then maybe you can add your own custom constraints. If there's any constraint that you try to implement but you don't know how to do, just let me know and I can have a look at it. And that's it. And thank you for listening to me.